Hey folks, welcome to Calculus 2. Putting together this quick little video for you to basically serve as our first day of class. The first day of class, well, we don't have class because it's Martin Luther King Jr. Day, but I just kind of wanted to go over some stuff because we're going to hit the ground running in Calc 2. So the first thing is I just wanted to go over the general format of how this course will be run in the age of a global pandemic. For those of you that suffered through Calculus 1 with me, you know what the format is. For those of you that are new, let me tell you what the format is. Every section is going to be handled by a video that I've made covering the section. The videos that I make are as close as possible to replicating what happens in the classroom. So when you're watching them, you should be taking notes. So what I would do in the classroom is I would go over some material, I would do an example, and then I would put another example on the board and ask you guys to work on it. And then I would do it at the board, we'd do it together to make sure that you're getting the concepts. So in my videos, you will see examples, and then I'll head off to the chalkboard here to work through the example. And most of the time when I'm done with an example, I am going to ask you to do one or two of your odd exercises in that section. I'll ask you to pause the video, do those odd exercises, and then restart the video, and I'll be at the board working through them to make sure you have them correct. So when you watch my videos, you pretend like you're in the classroom. One benefit, versus being in the classroom is you can pause the video, you can rewind it, you can watch it more than once. That's hard to do to me in the classroom. So since we only meet one day a week, generally what will happen on the days that we meet, and I'll talk about the academic calendar here in a moment, is you will hand into me a lab quiz that I will have posted on Blackboard, and you'll do the lab quiz, you'll hand it in to me when we meet. Then we'll go over the lab quiz to make sure that you're dialed in on the material, and I'll answer any other questions that you may have that has come up. Or I may foreshadow, talk a little bit about the material coming up for that week's videos. Generally speaking, I will be posting videos for the following week on Sundays. That's generally speaking. Generally speaking, I will post lab quizzes on Thursday or Friday that will be due on the next class meeting, which would be in a couple of days. It would be on a Monday. So let's talk about the syllabus calendar and stuff like that. You will find on the Blackboard side in the syllabus and content area, I have put a PDF containing the syllabus, so you should print that out and look it over. I may briefly talk about some items on it on the first day that we actually meet. But the one thing I'm going to highlight right now is, I have office hours on campus only 2 days a week, Monday and Wednesday, and it's generally right before our class meets. Like 9:30 to 10. So that's an opportunity to see me. The rest of my office hours I'll be conducting in my virtual office. And on the syllabus, I've indicated the days and times I'll be in my virtual office. I've also given the URL that you need to use to come see me in my virtual office. One comment about coming to my virtual office, the way WebEx is set up, that when you come to my virtual office, I believe what WebEx does is they put you in what's called a waiting room. And I'm notified that, you are in my waiting room. If I don't immediately admit you into my office, be patient. If I already have another student that I'm working with, I'm not going to, admit you in there because, we're getting 2 or more students in there at once. That could be a little chaotic. So be patient. I will not forget about you, and as soon as the office is clear, I will let you in. The calendar. I also have a PDF in the syllabus and content area called the academic calendar. That has all the due dates listed on it. It shows week by week the section coverage. It will show you on every Monday what lab quiz will be due, what sections that it covers. It also indicates when test dates are, and you will find also in there what sections will be covered on a test. So it has all due dates. So please check it out. And you might find some other stuff in the syllabus and content area. So that's basically a quick overview. Now some stuff that's more specifically content related. Stuff that I would mention on the first day of class before I got started onto the new material. The new material starts in section 6.2, and I have a video for that. So I would quickly, what I would quickly say is it's not possible for me to review all of Calculus 1. That's very impractical. So I would hit some high points, and I would say, I do assume that you remember all the derivative rules that you learned in Calculus 1. Derivative rules such as the power rule, the product rule, the quotient rule, the chain rule, all trig function derivatives. Yeah, I expect you to remember the derivative of sine is cosine. The derivative of tangent is secant squared. Also, derivative of some other transcendental functions. I'll list these over here. The derivative of natural log x, that's 1 over x. And I'm not going to write down the chain rule version of these. The derivative of e to the x is e to the x. The derivative of inverse sine, that's 1 over the square root of 1 minus x squared. Derivative of inverse tangent. Well, derivative of inverse tangent is 1 over 1 plus x squared. So that's just a few, that I'm listing on the board. But I do expect you to remember all rules of derivatives. So for example, and I would do a couple of quick examples. So for example, rules of derivatives. If you see the function square root 4x minus x squared, to get the derivative, hopefully you say, well, first rewrite that as 4x minus x squared to the 1/2 power. Now to get the derivative, 1/2 comes out front. You subtract 1 from the exponent, and then you remember the chain rule. The chain rule, you have to do the derivative of the inside function, which is a 4 minus 2x. Now, I'm not going to simplify that. I'm just wanting to review the calculus. If you see the function sine squared 3x, well, remember when you see a sine squared 3x, that really means the sine of 3x, that quantity squared. So the derivative, 2 comes out front, subtract 1 from the exponent, times the chain rule, the derivative of the inside. Well, the derivative of sine is cosine, times, because the inside function had an inside, you have to do the chain rule on that. The derivative of 3x is 3. So what about continuing to do some quick examples of derivatives? What if we saw the function inverse sine 3x? Well, the derivative is 1 over the square root of 1 minus 3x quantity squared times the chain rule, the derivative of 3x, which is 3. I'm getting that, I have that rule up here. I would go ahead and say the 3x quantity squared is 9x squared. So I would actually simplify this down to 3 over the square root of 1 minus 9x squared. What if you see the function, the natural log of x plus 1 over x minus 1? Well, this is one that I would start off doing some algebra. Remembering those laws of logarithms. I can rewrite this function as the natural log of x plus 1 minus the natural log of x minus 1. Then the derivative is real easy. The derivative is 1 over x plus 1. And if I use the chain rule, the derivative of the inside is 1, so this would be times 1, minus 1 over x minus 1. And again, if I use the chain rule, the derivative of the inside is 1, so that would be times 1. So one step of algebra makes the derivative very friendly. Let's do a couple of more quick reviews of derivatives, everything that you should remember from Calculus 1. So what if we see the function e to the 4x? Well, the derivative is just e to the 4x. And then the chain rule times the derivative of the exponent, which is 4. Or I might write that as 4e to the 4x. What if we see the function inverse tangent of e to the x? Well, this isn't bad. The derivative is 1 over 1 plus e to the x, that quantity squared, kind of looking like this rule, times, now I have to do the derivative of e to the x. That's the chain rule. So that's times e to the x. And yes, I would rewrite that, I would simplify that down to e to the x over 1 plus e to the 2x. So just some very quick, basic derivatives. Stuff that you should remember. Anything seems a little shaky, well, you have your book. You can go review the appropriate section. Okay, let's talk a little bit about integration. First and foremost, please remember, integration and differentiation are inverse operations. They undo each other, just like addition and subtraction, multiplication and division. And because they're inverse operations, you get some integrals for free. Here's what I mean by that. You know the derivative of sine x is cosine x. That means for free, the antiderivative of cosine x dx is sine x plus c. You get that for free because you know a derivative rule. Because you know the derivative of tangent x is secant squared x. For free, costs you nothing. The antiderivative of secant squared x dx is tangent x plus c. That's what I mean by you get some integrals for free. So, one more, I'm just going to verbalize this. Because you know the derivative of secant x is secant x tangent x. For free, you know the integral of secant x tangent x dx is secant x plus c. Let's talk about some some quickies that will help you through Calc 2 that you're going to start to see. Hopefully you saw this in Calculus 1. The antiderivative of e to the 3x dx. So maybe back in Calculus 1 you would have seen this was a basic u sub, letting u equal 3x, and you end up getting the antiderivative is 1/3 e to the 3x plus c. And if you did a couple more of those examples, you would be able to generalize to a little formula. E to the bx dx, as long as b isn't 0. The antiderivative of e to the bx dx is 1 over b e to the bx plus c. Again, as long as b isn't 0. That's a quick little formula. That's going to save you some time, especially when we learn an integration technique called integration by parts. Here is another one. I'll put that in a box. The antiderivative of 3 over 2x plus 1 dx. Yeah, we can do a u substitution, let u equal the denominator, and we end up determining eventually the antiderivative is 3/2 natural log absolute value 2x plus 1 plus c. And hopefully you would have seen a couple more of those examples and you would have generalized it to maybe something that looks like this. When you have a constant that I'm calling a over a linear function, so I'll write that as mx plus b, the antiderivative is a over m natural log absolute value of mx plus b. Folks, this is a nice, handy, it saves you just a little bit of work. It saves you from having to do a u sub. Knowing this is going to pay off when we learn an integration technique called partial fraction decomposition. Let's see, other highlights from Calculus 1. Oh, I don't know why I still have this up here. I can erase it. Give me a little more room. L'Hopital's rule, or as I usually call it, the hospital rule. I'm not going to write down everything that came along with, the preamble, all the words of L'Hopital's rule. I'm just going to kind of cut to the chase of it. Remember, L'Hopital's rule basically said that if the limit as x approaches a of f of x over g of x was of the form, the indeterminate form, 0 over 0 or infinity over infinity. And remember, infinity over infinity is how we represent the following four possibilities. Infinity over infinity, infinity over negative infinity over infinity, or negative infinity over negative infinity. So if this limit has one of those two indeterminate forms, and it's only valid when you have those indeterminate forms, then this limit is equal to, and I usually put the L up here to say I'm cranking it through L'Hopital's rule. The limit as x approaches a, f prime of x over g prime of x. So a quick example here of the old hospital rule. Let's say you're asked to find the limit as x heads off to infinity, 3x over e to the x. Well, substitution tells us that it has the form of infinity over infinity. Because it's infinity over infinity, I can take it to the hospital. Only when it has one of those indeterminate forms. I can only do it on the indeterminate forms 0 over 0 or infinity over infinity. And if I take it to the hospital, see, derivative of the numerator is 3, derivative of the denominator is e to the x. As x goes to infinity, 3 over e to the x. That's heading to 0. Let's see, how about more generalities from Calc 1? remember that the derivative of a function tells us where a function is increasing or where it's decreasing. So you remember back in Calculus 1, you were given a function, you would get the function's derivative, you would find the critical numbers. And remember, critical numbers are wherever the derivative is equal to 0 or where it's undefined. Then you'd make a sign diagram. And wherever the derivative was positive, that's where the function would be increasing. And wherever the derivative is negative, that's where the function would be decreasing. You also learned that the second derivative tells us where the graph of a function is concave up or where it's concave down. So remember, wherever the second derivative is positive, the graph of the function would be concave up. Wherever the second derivative is negative, the graph of the function would be concave down. And remember, concave up kind of looks like a cup. Tangent lines would be below the curve. Concave down kind of looks like a frown. Tangent lines would be above the curve. Now, okay, just like I said back the first day of Calculus 1, you need to remember trig. You need to know trig, and I'm not going to review all of trig, you can't. But I expect you to know the unit circle inside and out. You need to know the unit circle. You need to know how to solve trig equations. You need to remember trig identities, Pythagorean identities, power-reducing identities, double angle identities. These are the big ones that are used in calculus. And one final thing, and this is more of algebra. Remember, the nth root of x can be rewritten as x to the 1 over n. Some other rules of algebra. When you have b to the n multiplied by b to the m, so when the bases are the same and you're multiplying, you add the exponents. When the bases are the same and you're dividing, you subtract the exponents. And if you have b to the n raised to the m power, then you multiply the exponents. Oh, and one more. How about a negative exponent? B to the negative n, you can rewrite as 1 over b to the n. And of course, these rules are valid, as long as b doesn't equal 0, like for this rule and this rule here. These are rules that are two-way streets. In other words, you can rewrite a negative exponent like this. But you can also take a 1 over b to the n and rewrite it as b to the negative n. So, like I said, first day of Calculus 2, if we're in the classroom, this is about how much time I would take to review Calculus 1. Because you can't review all of Calculus 1. I'd be hitting the high points, and I would be saying, if I mentioned anything that you're a little shaky on, please review it. Take the beginning of the semester, the first day, right now, to review that. If you're a little shaky on the chain rule, review it. Derivatives of trig functions, review that. Review that now, because it's assumed that you are very proficient with it as we go starting off here in Calculus 2. So, that's it. So this would be basically what we'd be doing on the first day of class if we met, if it were not Martin Luther King Jr. Day and we were off. So I will see you the following Monday, which I believe is the 25th. It'll be the first time we actually meet face to face. You will be handing in a lab quiz on that day. So as I started this video, you need to watch you need to watch my videos for sections 6.2 and 6.3. Take notes as if you were in class. Do all the assigned exercises. Then do the lab quiz. and you'll hand that in to me on Monday, the first day we meet face-to-face, which I believe is the 25th. So that's it. Can't wait to see you in class on the 25th. Thanks for watching.